Okay, in the last class, we have just drawn some Born Haber cycles, and then I told you that in the next class, we would be discussing calculation part of the remaining chapter. So here is the recent paper 2023, paper 41. So this is the question related to the Born Haber cycle. They have given you a lot of data. Obviously, you have to choose your required data from this table. So if you can see that what they are asking in this question, select and use relevant data from table 8.2 to calculate the lattice energy of CaBr2 solid. It may be helpful to draw a labeled energy cycle. Show your working. This is of 3 marks. Yes. Yes, yes, yes. This is of 3 marks. Born Haber cycle. Yes, CaBr2, calcium bromide. Fast. Then I would be drawing fast solid. So I am drawing this. This is calcium solid. This is Br2 gas. What's the value that they have given us? Bromine, bond energy, okay. Electron affinity, okay. Ionization energy, okay. Hydration of calcium, atomization of bromine, then enthalpy change of atomization of bromine, then bromine bond energy, that is 192.9. Okay, yes. So first of all, I told you that you would be writing down this. What's the name of the process? This is enthalpy change of formation. This is enthalpy change of formation, basically, right? And then you would be calcium solid into calcium gas. This is what? This is atomization. This is what? This is atomization. Okay. And then first ionization energy of calcium. Bromine is the same. Then calcium is in group 2. So there should be a second ionization energy of, you can say, calcium. Okay. Then I would be writing calcium plus 2. Okay. Right. And then bromine. Calcium is ready to combine with bromine. Right. Okay. Then bromine. 2Br gas. This is atomization. This is atomization. Okay. This is atomization. Right. And then afterwards, after atomization, now electron affinity, because calcium, like the bromine, would be gaining 1 electron. Then bromine would be gaining 1 electron like this. That would be 2Br minus gas. This is electron affinity. They all are standard, so I am writing down, okay? Standard electron affinity. Okay. And then what I am supposed to write? They would be combining with each other to form calcium bromide, that is the lattice energy. Okay, that is the lattice energy. Hopefully you made this. Okay, so this was the structure. Okay. Calcium bromide. Okay. Now you have to select your relevant data from this table. You can take a screenshot. You can take a screenshot and then you can see what the values that are relevant and how you are going to calculate the lattice energy. Yes. Okay, first of all, standard atomization of calcium. I need atomization of calcium. The first value, this is 178.2. This is 178.2. Okay, 178.2 plus this is equal to delta HF. Okay, 178.2, and then I need the ionization energy for calcium. First ionization energy they have given, that is 590. Yes, this is 590. Then second ionization energy of calcium, that is 1145. Then atomization of bromine, because I have atomized bromine, right? I have atomized bromine. Okay, so what's the energy? Atomization of bromine is 111.9. 111.9. Okay, right? Okay, and then I would be multiplying this value by 2. Okay, because we have 2 bromines, and then I need electron affinity for bromine. First electron affinity of bromine is 324.6. 2 multiplied by 324.6. Okay, and then the lattice energy, that is unknown, I need to find out. And this is enthalpy change of formation, that is also given, like the formation of calcium bromide. Okay, that is minus 682.8. That is minus 682.8. So this is delta HF. Okay, yes, so now we can find out X. Let me rearrange this number. Okay, yes. Can you tell me an answer? It should be this. It should be this. Are you getting this answer? Mm-hmm. Mm-hmm.
Yes, sir, I am getting this answer. And I put the values in calculator.
Oh. Okay. Now you can see how the examiner asked related to the Born Haber cycle and also the calculation part as well. Okay. Now see this, another part. See another part of this chapter, hydration. We haven't discussed hydration. That's all for Born Haber's. Let me open another paper. 2023, paper 42. Same paper, different variant. First of all, you are supposed to draw the Born Haber cycle for Ag2O. Obviously, oxygen is -2. And I told you that you have to take care it because it's having first electron affinity, that is exothermic, and the second electron affinity, that is endothermic. First of all, you would be drawing the downward arrow, then upward arrow. Okay, and then the relevant data is given to you. So you are take a screenshot, and then I need your answer. I need your correct answer. fast. Take a screenshot and then see this Ag2O. This is Ag2O. Okay. Yes. Calculate this. I'm going to tell you answer. You should get minus 2968. You should get minus 2968. Okay, yes, now you're supposed to match. Time is over. I'm going to solve this. So first of all, Ag2O, right? Ag, 2Ag solid. O is half O2. Half O2. Why half O2? Because in the formula there is one oxygen only. This is formation. Okay. Then 2Ag gas. Then 2Ag plus 1. Then the same thing, but oxygen is atomized. Oxygen is atomized. Okay. And then, oh my God, no. Then this is atomization, ionization, atomization. Okay. Then again, electron affinity. This is first electron affinity. Then second. Hopefully you made like that. Hopefully you all like that. This is a Born Haber cycle for silver oxide, right? I'm putting the values to find out the lattice energy. Okay, let me just check the values. I need atomization of silver, that is 285. 2 multiplied by 285 because I have 2 silver. Then I need first ionization of silver, that is 731. Again, I would be multiplying by 2 because I have 2 Ag positive ions. Okay, yes, okay. And then I need what? Atomization of oxygen. Okay, so we have double bonded oxygen. Okay, oxygen has double bonded. So O double bond O is 496. O double bond O is 496. But I would be dividing it by 2 because I have only one oxygen atom. Then I need the 2 electron affinities first and the second. First electron affinity is minus 141. Minus 141. Minus 141. Okay. and I'm not multiplying and dividing this value by any number because we have a single oxygen. Okay, and then the second electron affinity is that is 798 positive. Lattice energy is unknown, that we have to find out. Obviously, enthalpy change of formation is given to you, that is minus 31. Yes, now you can calculate this. What's an answer?
Minus 2968.
Exactly. That's what I told you in the start. Kashaf, are you getting me? Tala, is that feasible for you? Are you getting my point? Hopefully this is easy for you, not difficult. Yes or no? Yes, Tala?
Yes,
You're
sir.
you're silent today. Okay. Okay. Let's start some difficult questions related to this. Wait. See this question. Part D. What do you think about this point? This is a good point. Good statement. Conceptual reason. Yes, I'm waiting for you, man. Yes.
Sir, first is
Mhm.
Ag2Se, then
Ag2,
Ag2S,
okay. Hmm.
then Ag2O.
But like, what is the basis of, you can say, uh, like the base of decision, that how we are deciding that this would be least exothermic? Least exothermic means the weaker ionic solid, and the most exothermic means a stronger ionic solid. I
Sir,
told
the
you
size of
that
the atom. The
yes,
size of the
exactly.
atom.
It depends on the charge and the size of an atom. So I think so. The charge is the same. Sulfur is -2, and oxygen is -2, and also you can say that um, selenium is also -2. So now we have to look at the size. So as we go down the group, the size increases. Okay. So I think so. Oxygen is the smallest. It should be most exothermic. And then sulfur is the middle. I think so. I didn't see the periodic table. Let me open the periodic table. Wait. See this. See, check your Se, selenium, and oxygen and sulfur. As we go down the group, the size increases. So yes, I was thinking right. Oh, so Se is the larger one. Se is the larger one. So it's having the weaker ionic solid, and it releases less energy. That's why they are saying it's less exothermic. So it should be on the first position. Then we have sulfur, and then we have oxygen. Okay, so they are asking the reason as well. So you would be writing that the size of selenium is more than sulfur, and the size of sulfur is more than oxygen. So as the size increases, so the force of attraction between the cation and anion decreases. So when the bond is going to be formed between the two oppositely charged ions, obviously they would be releasing the less energy as the weak bond is going to be formed. But on the other hand, if you have the two atoms having the smaller sizes, they would be having a stronger attraction. So when they would be reacting together, when the two oppositely charged ions are coming closer to each other to make a bond, obviously they would be releasing more energy. They would be releasing more energy because they are going to form a strong ionic solid. Okay, they are going to form a strong ionic solid. So yes, this is of 2 marks. Okay. Yes, Sahil, can you tell me, define the term electron affinity? Yes, Sahil. They're not asking standard electron affinity, okay, enthalpy change of. They're just asking what is electron affinity. This is of 2 marks. Yes. Sahil, what do you think?
Sir, it's basically how easy an element can gain electrons.
Uh, Element can gain electron. Okay. Energy released or absorbed?
Mm,
This is the main thing, that energy released or absorbed. Yes. Can anyone tell me? Yes. What
The
would you be
first,
writing? Basically, you are supposed to write in this, because this is of 2 marks, enthalpy change when 1 mole of electron is gained by 1 mole of a gaseous atom. That's it. Enthalpy change, or you can say energy change, when 1 mole of electron is gained by 1 mole of gaseous atom. Like, I'm supposed to write it, as you can see, so that you can make your mind. Enthalpy change when 1 mole of gaseous atom gains 1 mole of electron, and obviously after gaining 1 mole of electron, it would be having -1 charge. But that's it. This is of 2 marks. Yes. Next, write an equation for the process corresponding to the second ionization energy for calcium. Include state samples. Yes. They're asking to write down the equation for the second ionization energy for calcium. Second ionization energy means that it's going to lose its second electron. Obviously, they would be forming +2 ion after losing 1 mole of electron. And this is the calcium atom. This is the calcium +1 ion. Obviously, after removing the first electron, we would be removing the second electron. So after doing first ionization energy, we are going to have the second ionization energy. Okay. Okay, see this. This is the Born Haber cycle. Okay, you would be making it. Yes, yes. Now Subhan will tell me, suggest why the first electron affinity of oxygen is negative. Yes, Subhan.
Okay, sir. My voice is not lagging, right? It is fine, right?
Mm-hmm.
Can hear me, right, sir?
Yes.
Yes. So the question, you are asking part D part 1, right?
Yes. तो क्या होना चाहिए इसका आंसर सुभान?
Sir, answer here. Why first electron? Sir, it is negative because attraction between nucleus protons and nuclear charge and electron. Sir, it is
Basically,
negative attraction between nucleus. Like all the
basically
things
इसमें ये है कि
are
सुभान ionic, yeah, like I can say that since in the first electron affinity of oxygen, oxygen is neutral right now. Oxygen is neutral. There is no charge. When it's going to gain first electron, it would be forming O minus. It would be forming O minus. Obviously, this is an exothermic, and they have mentioned that this is an exothermic, right? So we have to write down the possibility, like why this is an exothermic, and you know that when the two atoms or molecules or ions are going to combine with each other to make a bond, so they just release energy. So the reaction is exothermic basically. So when this neutral oxygen is going to gain one electron, okay, it's going to gain one electron, so obviously they are going to meet together, they are going to react together. This is an addition reaction, okay. So the thing is that uh, oxygen is neutral. Yes, I know oxygen is neutral, and you know oxygen is neutral. Neutral means that this is an oxygen, this is a nucleus of oxygen, and 6 electrons are there in the outer shell of oxygen, okay, whose proton number is 8. Since this is an electron, obviously this is an electron. When this oxygen is going to gain this electron, just like that, okay, just like that, when it's coming closer to this oxygen atom, obviously they will be attracting with each other. Attraction between the nucleus, attraction between the nucleus, attraction between the nucleus and electron. Okay, there is attraction between the nucleus and electron, right? So when they are going to attract with each other, so they would be releasing energy. Simple, simple, it's very simple. So now you are thinking, sir, what am I supposed to write in this question? You would be just writing this is of 1 mark. Energy is released because electron is gained by the neutral oxygen, as there is attraction between the nucleus of oxygen, okay, and electron. There is an attraction between the nucleus of an oxygen and electron. So that's why the reaction is exothermic. That's why the energy is released. That's why the energy is released. Then the next, why the second electron affinity is positive. I told you, obviously, hopefully you just remember, I told you that in the second electron affinity of oxygen, right? So now the oxygen is negatively charged particle, and it's going to gain the second electron, and it's going to gain the second electron, okay? It's going to gain the second electron. So what am I supposed to do? This is oxygen O minus 1. Again, it's going to gain the second electron and would be forming O2 minus gas. Since there is a repulsion between the same charges, since there is a repulsion between the same charges, so what we are supposed to do, we would be overcoming this force of repulsion. Overcome this force of repulsion. Obviously, when you would be overcoming the force of repulsion, so you would be just providing some energy. You would be providing some energy. So this is the reason I can say that the reaction is endothermic. Okay, this is the reason I can say that the reaction is endothermic basically. Okay. Okay. So now they are asking the formation of calcium oxide. Okay, this is the part of. Oh. Can you tell me this now, Tala? Can you tell me this part F? Part F. Yes, Tala. I'm waiting for you.
Because calcium oxide has a stronger ionic solid.
Why? How can you say that?
They said that it's more exothermic.
Okay. They are
Which
saying the
means
lattice
that
energy of lithium
calcium is
fluoride is
stronger.
minus 1022 kilojoules per mole. Identify the factor that causes the lattice energy of calcium oxide to be more exothermic. Obviously, this is a stronger ionic solid, so that's why then their energy is more exothermic than lithium fluoride. You can see lithium fluoride and calcium oxide. Now see the difference. This is calcium oxide and this is lithium fluoride. Interestingly, it's +2 and -2. It's +1 and -1. How? But how? Calcium is in group 2. It's +2. Oxygen is in group 6, so this is -2. Lithium is in group 1, so this is +1. Fluorine is in group 7, so this is -1. Higher the charge, higher the force of attraction. I told you in the last class. Okay, so that's why they are asking in this question. Identify the factors. Identify the factors. So what are the factors? Basically, you can write, we have atomic radius. This is also the factor. Okay, like you can say that the charge, also the charge as well. Number one, this is of 2 marks. This is of 2 marks. First factor is the you can say the force of attraction between the two oppositely charged ions. If there is more charge, more attraction. Less charge, less attraction. This is the first factor. Okay, and the second factor is that like the charge density. Okay, but you would be writing the one factor and with the reason. Like you can say that the factor is the charge. Why? Because then you would be elaborating that higher the charge, greater the force of attraction, and obviously the lattice energy would be more exothermic. That's it. Okay. Yes. So you are supposed to do all the questions related to the Born Haber cycle, the calculation part, and that's it for all like the Born Haber cycle questions. Then we would be starting the enthalpy change of hydration and the enthalpy change of solution. Okay, that would be the last topic of this chapter, and then we would be starting the Gibbs free energy and entropy. But trust me, if you will not do these questions, you would not be able to understand solution and hydration, because they are interrelated topic. And then we would be discussing the group 2 solubility, and trust me, you will not be getting solubility as well, because they are interconnected topics. Series, you can say that they are in series, they are in loop basically. So if you are not going to gain any one of the lecture, so you will not be getting the coming lectures. So this is important to know, and keep doing past papers related to Born Haber cycle. Okay.